Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a new concept regarding radial flow reaction turbine. So we have discussed about the turbines and turbine types, and we have seen that turbines are different categories are there, like based on the energy, based on the flow directions, based on the specific speed, based on the heads. So there are different types of turbines are there. So in our last video lectures, we have discussed about the impulse turbine, and in that example is Pelton wheel or Pelton turbine. So we have completed that one. And this is the new one, that is radial flow reaction turbine. Actually, first one, if you see that the radial flow turbine, in this radial flow, the water will flows in the radial directions. That's why it is called radial flow turbine. So the water will be flows in radial directions. First thing. So if you see, this is one example I have taken. This diagram I have taken from the book. The water will be come from outside through the paint stocks, and it will be goes through this turbine, and it will flows like a radially. Okay, that's why it is called radial turbine, radial flow. So flow of the water will be radially. So it is called radial directions. And in this radial directions, again, actually, this radial flow reaction turbine is two types. One is inward flow reaction turbine. Another one is outward one. So I'll tell you here. In the radial directions, actually, the water, it may flow from radially from outward to inward. Okay, when the water will flow from outward to inward, from outside to inside, or you can write inward here. When the water flows outward to inwards, or the water may flows again in the reverse ways. The water may flow from inward to outward, from inward to outward. Okay, and when the water will be flows from outward to inwards, that is towards the axis of the rotation. And from when it is when the water flows from inwards to outwards, then that is different. So if the water flows from outward to inward through the runner, then this turbine is known as inward radial flow turbine. This one, this is inward, we can say inward radial flow turbine. Okay, similarly, when the water flows from inward to outward, then it is called outward radial flow turbine. Okay, now next concept is, what is reaction turbine? We have seen impulse turbine, and now we'll discuss about this reaction turbine. So in the reaction turbine also, we have seen previously, like I have told you the definition of this reaction turbine. In this, actually, the water at the inlet of the turbine, if you consider at the inlet of turbine, it possesses both kinetic energy as well as pressure energy. Both kinetic energy will be there and pressure energy will be there. But while in the impulse turbine, it is only kinetic energy to strike the turbine blades. But here in the reaction turbine, if you see, when it is coming through these penstocks to this turbine, it is to have both, like kinetic energy is to there as well as pressure energy is to there in the liquid which is flowing through this one. Okay, and that turbine is called as reaction turbine. So when the water flows through the runner, here when the water flows through the runner, where the, okay, some parts are there in this. Let me tell you, this is, as you can see, this is penstock is there. Okay, this is penstock is there, which came from the dam, and through this penstock the water will become inside. And here if you see, this water will be flows through a casing, and that casing is called as a spiral casing. Actually, it's like a spiral type is there. And the casing diameter also, if you see that diameter of this casing is area, you can say, or diameter, it's kind of gradually decreasing mode. It is in gradually decreasing. How much area was there at this entry level? If you come slowly to this inside one, this area of this casing is decreased here. Okay, so this will be give an impact on the flow. Anyway, so this is about the spiral casing. So how many components are there? First one we can say one is casing. One is casing is there, and second one is this one, that flow which is coming through this penstock and through this casing to inside. So once it goes inside, like it, the flow direction you can see. This is the flow directions are there, and the flow will, the water will be flows. It will be moves inside through this veins, and these veins are called guide veins, and that is established, or that is situated on the guide wheels. So next is guide veins and guide wheels, so that will become under the guiding mechanism or guide mechanism, we can say. This is the second. Third one is, if you see, once the water goes through these guide veins to inside, then we have a runner part is there, and this part is called, this inside part is called runner. You can say the wheel is nothing but runner also. So this is outer one and this is inner one, we can say. This is outer wheel, this is inner wheel, and the wheel is nothing but, we used to call technically, this is runner. And inside the runner we have the, in the runner we have blades are fixed in this. Okay, if you see, these are the blades are there which are fixed on this. This is one blade, this is one blade, this is one blade. So all these things are one blades, or used to be called as a vanes. Okay, so this is the next one, and the last one is, that is draft tube. The last one is draft tube. I'll tell you one by one all this working principle of this first. When you consider the first one, the casing part, then at the starting I can say that when the water is coming from the outside, then it will goes through this casing to inside. And before that, we need to remember one thing. In the reaction turbine, as I told you, that kinetic energy as well as the pressure energy both have a impact on the entry level of this inlet. Okay, when the water flows through the runner, the pressure energy will be continuously, it will, it is going to change to kinetic energy. It is going to change in the kinetic energy. So the water through the runner will be under pressure, and the here this runner part, actually it will be always in the enclosed medium, and it used to have inside the water only, always full of water is there. I'll tell you the concept of this pressure difference in this reaction turbine, how the pressure used to have a major key roles in the reaction turbine. Now, as I told you, casing, so this is this is a case part, the covering part of this reaction turbine, and it is to always full of water. This is to always full of water. And as I told you, the water which comes from the dam through this penstocks, and it used to enters through the casing, and the casing is, what kind of casing is there? That is spiral casing. In which, as I told you, the area of the spiral casing, or area of the cross section of the casing is continuously decreasing. That is called gradually in decreasing area. So when it is decreasing, then obviously we can say the velocity will be increased at this point, like the speed or the fluid velocity will be increasing that. Okay, and as I told you, that is always completed in full of water. Okay, and the casing used to made of different materials. it may be made of concrete, it can be made of in cast steel, or it can be made of in different materials also, some other hard materials. So we choose to protect the turbine part. So this is the casing part. Next one, the guide mechanism. In the guide mechanism, if you what I told you, that it consists of a circular wheel type. Okay, the guide mechanism is nothing but this one. If you consider only the guide mechanism, which is inside this wheel, all these parts are coming under this guide mechanism. Anyway, only will consider this outer part of these. These are also blades. Okay, these are also blades which are fixed on the wheel. As I told you that the water will come from outside, and it is to take a entry from this fixed vents to inside. It is to go inside. So this fixed vents are the path directions, or you can say it is the it shows the direction of the fluid to goes inside the runner. So in the guide mechanism, as I told you, that it's considered of a circular wheel is there. Circular wheel is there in the turbine, and these guide vanes are having like a number of vanes are fixed on that, and yeah, number of vanes are fixed on that in equal you can say positions or the distance. Okay, the next one is runner part. So runner actually, this is also a circular wheel. As I told you, this is also circular wheel, and here in the runner also, it is also a circular wheel. In this, a number of curve vanes. Previously also the same curve vanes are there. A number of curve vanes are fixed. Okay, and here these vanes are very smooth. These vanes are very smooth, and the radial curve vanes means, here if you see, the radial curve vane means the water will be enters and leaves the runner without any disturbance, without any shock. Okay, and these runners are it's made of cast steel, or you can say cast iron also. Cast steel and cast iron, or you can say it is made of stainless steel. And this runner is fixed on the shaft. This one is the shaft part, and this runner is fixed on the shaft. So this is the working principle of this runner. And the last one, as I told you, draft tube. The last one is draft tube. So draft tube actually, it is to be used for to maintain the pressure. As I told you that there is a pressure difference which occurs in this reaction turbine when the water flows from outside to, and it leaves exits from the shaft part or runner part. I'll tell you that how this pressure difference happened. Let's see draft tube. So the pressure at the exit of the runner, actually, the pressure at the exit of runner is very low. And this is to keep the negative pressure impact on the turbine. So because when the water will be comes out from this turbine at the runner condition, if the pressure is very low than the atmospheric pressure, then it will have a problem. So the water cannot exist from the tail race. Cannot be exist to the tender, because outside is high pressure, inside is low pressure is there. So the draft tube will be used. Okay, so its shape will be like this. It's gradually increasing mode. Okay, the pressure at the runner will be low, and if you fit a draft tube at the runner part, then what will happen? Slowly the velocity started increasing, and the pressure is started increasing and velocity started decreasing, and it used to have more than the or equal to the atmospheric pressure, so the water can easily exist from the draft tube to outside. Okay, so this is all the components what are used in this reaction turbine, and as I told you, this is a radial flow reaction turbine. But what we have discussed here, this is exactly inward radial flow reaction turbine. This is actually inward radial flow reaction turbine. And in this radial flow reaction turbine, one example is Francis turbine. One example is Francis turbine. Yeah, here actually I have taken the example of this Francis turbine. This one you can see, as I told you, as I have explained you, that the water will be comes from the outside through the, and it will be goes to this penstock, and the directions will be like this. The water direction will be like this, and the water will be moves inside this one. These are the fixed vanes. These are the fixed vanes. Okay, or you can say this is guide vanes. Here it is given. You can see these are the guide vanes. And these are the stay vanes, and inside this is a wheel. Okay, and once the water goes inside, okay, it used to impact on the vanes which is fixed on the runner here. Okay, then it started rotating. So this is the view of this inward radial flow reaction turbine, and which is also known as Francis turbine. So actually, the Francis turbine was invented by a scientist. His name is like J.B. Francis. This is invented by a scientist called J.B. Francis. He is an American engineer who designed this one, and this Francis turbine actually it is coming under the inward reaction flow turbine. Okay. Now in the modern reaction turbine, actually another one is there. In the modern Francis turbine, the water used to come radially and it used to goes out axially. Okay, in the modern Francis turbine, the water used to come inside radially and it used to go out by axially. That's why it is called mixed flow. Radially in, like inside, and when it is going outside, it's going axially. This is when it is going outside. That's why it is called mixed flow reaction turbine. That's why it is called mixed flow type reaction turbine. Okay. Now, as I told you already, that I'll tell you the pressure difference, how the pressure difference or how the pressure mechanism is working here, or how the pressure difference created here in this. I'll tell you one by one. In the Francis turbine, yeah, let's come to this one. Here also the similar diagram of the inward reaction flow turbine or Francis turbine is there. So how this pressure difference will be there? In the Francis turbine, first one we can say that before entering to the turbine, or you can say before entering to like guide vanes. In this, if you see, this are, as I told you, these are the guide vanes are there. This is our guide vanes part is there. Okay, so before entering to this one, what we have the pressure of like high pressure will be there, and like velocity will be normal, velocity will be there in this. So what you are seeing, like velocity is increased, like velocity in the higher mode when it is coming through this pipe, and before entering to this one. Even at the high pressure, it enters to the this turbine. Okay, and yeah, next is when it is crossing the guide vanes. When the water crossing the guide vanes. When the water crossing the guide vanes. So the guide vanes actually it acts like a nozzle. This is to works like it acts like a nozzle which will control the flow directions. it will control the flow directions as well as it also partially it is to convert the pressure energy, or it is to convert the pressure energy to kinetic energy. This is actually partially, not fully. So what is the work of this guide vane? When it is entering to this one, the structure of this, you can see the blades, and this blade mechanism actually it helps. So as I told you that this guide mechanism, it's used to control the flow directions, and partially it is to convert the pressure energy to kinetic energy. So in this way, what will happen? Your pressure will be decreased, your pressure started decreasing and velocity started increasing. In that, again, the water will be the water will started flowing inside the runner. Now it is to move to the runner. Now again, third step is when the water inside the runner, when the water is inside the runner, okay, as I told you, the water like flows radially. You can see the water flows radially through the curved runner blade. Here the blades are, you can see, all are curved out there. So due to these curved vanes, okay, the water started expanding. The water started expanding, okay, or you can say the flow expanded here, because due to the curved runner blades. Okay, so in this, again, when it started expanding, your pressure also started decreasing. Okay, so pressure also started decreasing here. Now at this point, if you see, your pressure was in decreasing mode or less. So the difference of pressure between the blade, you can see this is the blade pressure side and this is the suction side, suppose. Okay, so the difference of this blade pressure side and the suction side of this you can say of the suction side of this turbine, okay, this provides actually a reaction force. Okay, this provides a reaction force, and that reaction force or this force is to help to rotate the runner. Okay, this reaction force or this force which is created by the pressure difference of this, it used to helps to rotate the shaft. That's why it is called a reaction turbine. Due to this reaction force is created in that, due to the pressure difference, that's why it is called reaction turbine. And due to that, it started rotating here. This is inside the runner part. Now at this, the pressure difference inside the runner, actually the pressure difference which we got here now, the pressure difference inside the runner, it used to create the turbine power, or it is the main source of turbine, because due to this that shaft started rotating, and this is to give a turbine power. Actually, you can say the power which is created at this point. And the next one is the exist part. This is about the enter part inside the runner. Okay, now when it's completed, it started existing from the runner, or we can say it is the entry of draft tube. Here you can see this is the draft tube is placed at the exist of the runner. Okay, as I told you, at the exist of the runner, the pressure already decreased here, so pressure is in low, very low at this exist of the runner. So water will be exist from the runner to the draft tube. Okay, and the draft tube, if you see, it is connected, it is inside the tail race, and here we have the like atmospheric pressure will be there in that, but the pressure which is coming here, it is very low. So this draft tube, what will do here, the draft tube work, as I told you previously, it is in gradually increasing mode. That means area is more here, so that the pressure started increasing at this point and velocity started decreasing, because we know that PV, as per the continuity equation, PV equal to constant, we can say, or we can say that Q equal to, that is AV, not PV, this is AV actually, A1 V1 equal to A2 V2. So once area increased, velocity decreased here. So here we'll get pressure continuously increasing here and velocity decreasing, and that will allows the water is to now will be come out from this draft tube to this tail race. So this is the use, or you can say that application of this draft tube in the reaction turbine. It is very, very essential in this. So this is the part of, as I told you, working of reaction turbine, and this is inward reaction flow turbine, and the Francis turbine is one of the example in this. And the thing is where we can use these applications. The applications can be done in many places, like I can say that hydroelectric power plant. This is can be used at hydroelectric plant to produce the electricity. Okay. Similarly, it can be used in the turbochargers. It can be used as a turbochargers. And similarly, also you can use this in the gas turbine also. These are the few examples of this reaction turbine, inward reaction flow turbine. And along with these, we can say some advantages and disadvantages of this. Like advantages, if I tell you that its efficiency will be always like a moderate efficiency will be there, not high, not low. So efficiency is, we can say, good. And design will be very, very compact in design. Okay, we can say a compact design and robust design. And these are the some advantages I can say. And some disadvantages also can be taken in this. Like sometimes cavitations will be formed. Cavitations will be formed. Why this cavitation will be formed? Due to the pressure difference. Okay, so we need to avoid this. And the cavitations can be formed on high pressure actually. This cavitation will be formed in the high pressure. Normal pressure, there is no issue on that because power need to be also generated. So when it is high pressure will be there, cavitation will be formed. And cost effective also we need to look after, because some high cost would be invested on this for the large scale design. So these are the basic working principle and mechanism of this reaction flow turbine. And as I told you that this is inward radial flow reaction turbine, and which is nothing known as Francis turbine also. I hope you understand this theory. Still, if you are having any doubt regarding this, you can give a comment on the comment box. Thank you all.